Swayam Prabha. Digital India. Educated India.
Yeah, good afternoon. Welcome to the course Comprehensive View of Speech Processing, and today's lecture is 9 in the lecture series. Today we are going to discuss about knowledge sources that are present in a speech. So, as we aware of that already in the introduction, during introduction we learned that speech signal carries different types of information. So, that is the reason that when you are talking about the speech processed by machine, we have different types of tasks that will be carried out by machine, like a speech recognition, speaker recognition, language identification, speech enhancement and so on. So, like as have a speech signal and it contains different types of information. As a human, we make use of all these information at different levels or different points of time depending on the requirement without any effort at all. But if you want to perform a similar activity or similar thing by the machines, so we expect the machines also to make use of these knowledge sources as and when they are required to perform the various speech tasks. And in the first place, let us see what are the various types of information that is embedded in the speech. Here I just listed out a few of the like some important types of the information that is present in speech. It is not only this list of types of information that is present in speech, is much beyond that, but here I just listed the important ones over here in this slide. So, the first one, the very important one or the very crucial one is the message. So, in a speech signal, first of all, the speech signal is meant for the information exchange, or like for the purpose of if you want to convey something to your the other person. So, so for that purpose we generate the speech and then it will be communicated. So, the message is the very crucial part or the core part of the speech, and it is nothing but a thought to be conveyed. Suppose whatever you want to convey to your friend or to the other person, so that thought to be conveyed. So, that will be, that is present in a speech in the form of a message, right. So, whereas in the from a machine perspective, so we view this message as the text or the sequence of words associated to a specific language, right. And whereas from a human perspective, the message means it's a bit abstract one, like where both the person whoever is generating a speech or whoever want to convey his thought or his some information, and the other person or the person whom it is intended for. So, both of them can able to, like the person who want to convey that and the person who want to intend it for, both of them will understand what the other person is conveyed and what to be conveyed, right. So, then along with the message, the speech signal also carries the information about the speaker or some speaker specific characteristics. That means who the speaker is. So, the same speech signal or the same message, suppose if it is conveyed by 2 or 3 different humans. So, even though the message part remains same, but if you listen to the speech, immediately you can able to make out that. So, these 3 signals or these 3 speech utterances are spoken by different people, right. So, that way the speech signal also contains the information about the speaker or the speaker specific information, or you can say that the speaker identity is also embedded in the speech signal. And along with that, language. So, this we have already learned in the very first class itself, because as we mentioned that speech is always associated with a language. So, if there is no language, associated, or if we do not associate a language with a speech, then it cannot be a speech at all. It is like you can say it is a sound, say that it is a sound, it is not a speech at all. So, therefore, a speech also carries the information about a language, and we learnt what is meant by that. It means in each language there are some valid sound units associated to a language, and again the sequence of those sound units also, there are certain legal sequences are valid. Okay, some it's not that all the sound units, whatever the sequence, that cannot be the valid, or it cannot be legal for a particular language and all, and likewise the word sequences also. So, that way when the moment once you associate speech with a language, then whatever the language constraints are there, all those language constraints are also superimposed or also obeyed by the speech. So, therefore, the speech also carries the information related to a language, and then the naturalness. So, it means that whenever a speech produced by humans, most of the times we will feel that the speech is natural, or will feel very comfortable for while listening to the speech produced by humans and all. And among the humans also we will feel that some people's speech will be appears to be more pleasant, or more appears to be like more pleasing effect compared to the other speakers and all. So, that depends, that is what mean by naturalness. So, mostly the speech produced by humans is more natural, and here whatever the pleasing quality of a speech, so that is mostly attributed to the naturalness of a speech. So, here actually the moment once as a humans produce a speech, it appears to be more natural, or it is of, we can say that it is a natural speech. And we can from a machine perspective, if you synthesize the speech by machine, or if you generate the speech by machine, then that speech will be very different from appears to be like a more different from a natural speech. So, because of various reasons, so there you can able to clearly discriminate or clearly distinguish, clearly see the lack of naturalness in the speech produced by machines. Right. And later we will see that slowly what is the reason for the naturalness in a speech, and what are its characteristics, all those things we will see a bit later. And the other characteristics or other types of information that is also present in a speech known to be intonation. So, intonation is nothing but increasing or decreasing of a pitch. So, here a new term is introduced known to be pitch. So, pitch is nothing but, we come across the term pitch when you are discussing about the types of excitation, voiced excitation and unvoiced excitation. So, here pitch is nothing but the rate of vocal folds vibration. Here we have vocal folds at a glottis, at a laryngeal cavity we have vocal folds, and speech is produced during exhalation process, and during the exhalation process these vocal folds vibrates, and that acts like excitation to for the production of speech, and this excitation is known to be voiced excitation and all. And here the rate of vocal folds vibration is nothing but number of times the vocal folds closes and opens, right. So, that indicates the pitch, that indicates the pitch. Whereas, in a waveform point of view, you can able to see that the pitch in terms of the periodic pattern. That means, in a waveform the same pattern or the same signal pattern repeats in a successively. So, that way you can say that a signal is periodic, signal is periodic. So, the pitch is nothing but number of times the periodic pattern repeats in a second is known to be pitch, right, and the pitch period is known to be inverse of that. What is the time that is required to have one pitch period, one period of a signal and all, it is known to be pitch period. So, the reciprocal of pitch period becomes is nothing but a pitch, because the number of the cycles, number of the periodic patterns, number of those periodic pattern per second will be viewed as a pitch, right. So, where for a humans, where for a male speakers usually the pitch is around like around 80 to like 130, 140 or up to 150 for a male speakers, whereas for female speakers it varies from like 170 to like close to 300 and so on, like it's around 200 to 30 something like that. So, so that way you can the male speech versus the female speech, you can clearly discriminate the male speech versus female speech because of the variation in the vocal folds vibration. So, usually the female speakers pitch will be 1.5 to 2 times more than the male speakers speech, So, here the intonation refers to the variation of pitch, it can be viewed as intonation, because you can say that the vocal folds vibration is not constant, they vary with respect to time, that depends upon the sound unit and depending upon the speaker and depending upon the sentence, different words where the pitch varies and all. So, that dynamics in a pitch will give you a naturalness to the speech. Otherwise, suppose if you maintain the pitch as uniform across a sentence, then it appears to be very unnatural, right. So, here the pitch, the intonation patterns, that depends upon the type of a sentence. Suppose if the sentence is a neutral sentence or a declarative sentence, where you can say that the pitch varies monotonically in a decreasing way. It means at the beginning of a sentence you have some pitch, and afterwards when you following as you progress through a sentence, if the sentence is a declarative sentence or a neutral sentence, the pitch gradually decreases at a global level or at the end of a sentence. You can able to see a decrease in pitch from beginning of a sentence to end of a sentence for a declarative sentence, a margin of around 20 to 30 Hz you can able to observe, right. Whereas the interrogative sentence is the other way, the pitch will be rise or you can able to rise in the pitch as the sentence progresses if it is interrogative sentence and all. And similarly the exclamatory sentence or different emotions and all, where the pitch or intonation patterns or intonation will be different. So, all those things will be a part of a speech. Likewise, similar to the pitch or pitch patterns, we have a duration patterns, it's nothing but variations in the duration patterns. So, it means that when you are uttering a sentence or when you are speaking, it's nothing but you are uttering a sequence of sound units, and for every sound unit it has some inherent duration, and depending upon the context the duration of the sound unit varies and all sound, and that depending upon the semantics or depending upon the other like emotion content and so on, the meaning that is associated with respect to that, the sound units, the durations of sound units varies and all, right. So, these duration patterns are also as an important information with respect to speech. So, the duration patterns here are different levels. So, duration patterns of the sound units are the duration patterns of syllables, then the durations of words and durations of phrases. So, all these things also provides you the different information depending upon the message you are conveying. And then you have like the stress patterns, right. So, it means that when you are uttering the speech, you are it's not that you are uttering all the words with equal emphasis, you can see where when you are uttering a speech or a sentence, certain words you try to emphasize more with respect to the other words. So, it becomes more natural. Otherwise, suppose if you speak all the words with the same intensity or with the same emphasis, then it will not be more natural, or it's not at all natural. It almost like appears to be like a monotonic. So, for example, when a person speaks or when a person narrating a story, so you can able to see that when he is narrating at the beginning of a story, so his way of expressing the words will be different compared to at the middle of a story or when he reached to the climax of a story and all. So, here all these things because if you emphasize selectively for different words and phrases, then it becomes more natural and it will be pleasing or it will be more comfortable for the people whoever is listening to the speech also. Like then accent, that depending upon the person, like people in a different geographical regions will speak in different ways, right? That depending upon language, even though people may speak the same language, but based on the geographical area, so the way they speak the language, the way they utter the words will be somewhat unique or somewhat different from the others. So that's nothing but the accent, and that depends upon the dialect region of a person and all. That means we have the same Hindi, for example, in our Indian context, the Hindi language is spoken by, like there are multiple states, and the people from Bihar speak Hindi, people from like UP, Uttar Pradesh, they also speak Hindi, and people from the other, some other state, Delhi also they speak Hindi, but you can able to clearly notice the way they speak Hindi, the same language, in different ways based on their geographical region, and that also embedded in the speech. That means nothing but the accent or the dialectal region of a person is also embedded as one of the information present in a speech. And along with that, the emotions, like based on the semantics of the information to be conveyed, right? You will express the speech in different emotions, right? That depending upon the semantics, that depending upon the context or environment, we express the speech in different emotions, and that will be more natural, right? Likewise, here you can see the health is nothing but one is the health of the speaker, and along with that, the health of the speech production organs. Speech production organs means like it constitutes like lungs and the windpipe, then the laryngeal cavity, vocal folds, then the pharyngeal cavity, and different organs in oral cavity, nasal cavity. All these contributes to the organs that are participating in the speech production mechanism. And if there is any problem, or if there is any like the imperfections, or if there are any issues that arises in these organs, so that also can be observed related to that, any disorders or anything. So those things can be observed from the by analyzing the speech, or as part of the speech signal, even that also carried out by a speech signal and all, right? And finally, the device and channel. So here the speech signal to be processed by machines. So we capture the speech signal using a sensors or a transducer known to be microphone, right? And so the speech signal that is captured by microphone, so the speech that is acquired through a microphone, so that the characteristics of that speech that is recorded by microphone, it depends on the characteristics of a microphone, right? And then it also depends upon the medium, like from the speech is originated at some place, and then the mic is there, through mic you are capturing that, and wherever you are uttering the speech, or wherever the speech is captured, so that surrounding environmental noise or environmental is also captured when you are acquiring the speech signal. And that means the speech signal also carries the information about the microphone and the characteristics of a channel. Suppose you are recording or you are capturing a speech signal in a quiet room, so where the dominant characteristics that are observed in a speech will be only the microphone characteristics will be there, because here the speech, here is a very quiet room, so there won't be any other disturbances that are present in capturing the speech. But if you are somewhere in outdoor, or if you are under a fan, or if you are very close by the AC machine, you can able to have some whatever the noise that was generated by fan or noise generated by AC machine, or otherwise the wind blow at outdoors. So all these things are also part of the speech signal that you can able to observe. So that way, what I want to convey here is that there are different types of information that is present in a speech, and as a humans we are using this knowledge that is present in a speech at a different points of a time for various activities. So the same way, when you are processing the speech by machine for performing various speech tasks, So, one should exploit these knowledge sources effectively, so that the accuracy of the performance, or the performance accuracy in this in the targeted speech task will be better. And here one way to here have displayed a speech signal, and here the speech signal is uttered in a continuous manner, in a continuum, and here this speech signal corresponds to the message माता और पिता का आदर करना चाहिए. So, this is the Hindi speech utterance, like, and here the message that is to be conveyed by using the speech signal is माता और पिता का आदर करना चाहिए. So, from this you can notice that this particular speech signal corresponds to about there are 7 words like माता और पिता का आदर करना चाहिए. And if you count the number of syllables, so here the syllables means ma is 1 syllable, ta is 1 syllable, aur is 1 syllable, p is 1 syllable, ta is 1 syllable. So, likewise usually the syllable means, so yeah, it is a unit, it is a sound unit, or you can say it is a combination of sound phones, or you can say it is a sound unit where the vowel should be present and consonants may or may not be associated with it. Consonants may or may not associated with it. So, usually the syllable will be represented by C power n, V, C power m. So, it means that here this n comma m may be greater than or equals to 0. So, what it means here is that the consonants may present or may not present, but the vowel should present. The vowel should present. So, therefore, this vowel is known to be nucleus of a syllable, and these associated consonants, they may present, may not present. For example, here in case of like mata or pita ka adar karna chahiye, where in that adar, where a is a syllable. So, in that case where a is a vowel, where a is a vowel alone, there is no consonants that are associated with that. And whereas, for example, in case of mata, where there are 2 syllables ma and ta, in case of ma you have a syllable, like this is the syllable corresponds to ma will be CV. It means the consonant m, the nasal consonant m, and then followed by vowel a, so it is a CV, right. So, likewise we can define the syllable as it is of a structure C power n, V, C power m, where this m and n will be greater than or equals to 0. It means that if it is equals to 0, it means that the syllable constitutes only the vowel, and if it is non-zero, then the consonants are present. That depends upon like there may be sometimes the consonant preceding this vowel, sometimes there will be consonant following the vowel, sometimes there will be consonants both preceding and following also will be present. So, that way we can able to define the syllable and all. And usually the here the individual sounds are known to be phones, that we already defined, right. So, the characteristics of phones are very much depends upon the context, the adjacent phones. So, compared to the phones, the characteristics of syllables are somewhat stable, somewhat more stable. And in the Indian context, our alphabets, or you can say that you can say the written font is close to the syllable, is close to mostly syllable, right. So, here that way here, as I mentioned here, we can say here yeah, here as I mentioned here, this is a speech signal corresponds to this particular sentence, mata or pita ka adar karna chahiye, and here it was plotted, this is a time domain representation of a signal, and you can see that here the number of samples here that were plotted here will be this is up to 2, and then maybe it is a 0.5, 2.5 into 10 power 4, that means there are 25,000 samples that are present here in this signal, in this display. And you can see that from this display the signal amplitude is varying based on the sound unit, and here the amplitude takes multiple shapes, like at some points the amplitude is high and at some points the amplitude is very low. And you can also see that here, since the signal is there are 25,000 samples are shown in a very shorter window. So, therefore, you may not observe the periodicity with your naked eye, but actually if you like zoom this signal or if you stretch this signal, you can clearly observe the periodic patterns in this speech signal, and that you can able to observe here in this speech signal. Here you can able to see the vertical lines, the separations over here. So, these are the indications of like the periodic patterns where the peaks in this period, each period is represented or can be observed over here and all. And here from this speech signal, here depending upon the sound unit, the amplitude of the signal varies, right, and also the depending on the sound unit, you can see the periodic patterns during the vowel regions and the noisy patterns during the like unvoiced or consonant regions, right. And we have a voice region, the lower amplitude corresponds to the nasals. So, there is some information you can able to see from a time domain signal. What you observe over here is that the signal contains very low amplitude during the no signal or a no speech, and during the other places as per the sound unit, the signal amplitude is varying, right. And when we utter the speech signal, so for the convenience of speaking the utterance, or at the same time for the convenience of listening purpose also, we will leave some pauses in between the words, right. And so that becomes that makes you the speech will be more natural. Otherwise, suppose we speak continuously without leaving any pauses and all, it will be difficult for a speaker who producing the speech, and as well even for listening to the speech also, inferring the message out of that will be very difficult if you don't have any pauses between the phrases or words in the speech. Yeah, next we move on to the here this in this particular slide we displayed the top figure or the subplot. This is corresponds to a speech signal. The top figure corresponds to speech signal S of t, right, and the same signal whatever is shown in the earlier the same signal is observed over here, and here and along with that we have plotted some other information that is present in a speech signal using some signal processing tools, So, here you can see that the second plot over here are from top the second plot. So, this is known to be like the energy contour. So, this is derived from this plot. It indicates that in a time domain how the energy is spread, across the time. So, because we have the signal is uttered around 3 seconds or maybe, so yeah, that depends, like here for example the signal is sampled at 8 kilohertz. So, it means that per second 8,000 samples. So, there are 25,000 samples. So, it means that the duration of a signal in time is 3 seconds, but here it was plotted, here the scale was given in the form of number of samples. So, therefore, here the total number of samples present in a signal is 25,000 close to, and whereas if the sampling has been done at a rate of 8 kilohertz or 8,000 samples per second. So, it means the time interval for uttering this particular speech is 3 seconds, right. And here the intensity contour or energy contour. So, this shows that how the energy is spread in these 3 seconds, across these 3 seconds, right. So, wherever the sound unit is there for uttering the sound unit, so we have will have the more energy you can be observed, and wherever there is no speech you can able to observe the amplitude or the energy contour has very low amplitude. Energy contour has very low amplitude. So, from the energy contour, one can able to discriminate, or one can able to identify that where the speech signal is present, or where the speech or sound units are present, and where the speech is not present. That means where there is no sound units are produced or no sound units are observed. So, that you can able to make out from the energy contour, from the energy contour. That means from the given speech signal, if you compute the energy contour, then one can from the energy contour one can able to observe that where the speech is present, where the speech is not present, or where the silences are there. So, how do you compute this energy? So, for computing energy, we will just since here you can able to compute the energy for the whole signal. How do you do that? Just energy is nothing but just for computing the square of the squared sum of the samples amplitudes that gives you the energy. Squared sum of the sample amplitudes provides you the energy of a signal and all. But if you take the energy for the whole signal, you will get the overall energy that is present in the signal. Overall energy that is present in the signal. But that is of no use at all, because you will get one number, and with that we do not comment anything. Like we do not comment, we can say relatively that yeah, this particular speech signal has higher energy or lower energy. Other than that, we do not comment any other thing. And as we know that here the speech is constitutes of sequence of sound units. Each sound unit has specific characteristics. So, the signal whatever is shown here, this is not a steady signal, this is not a stationary signal, this is a non-stationary signal. So, therefore, when you are computing energy, so you need to compute the energy also for a shorter segments, for a shorter segment. So, that is the reason that we have to split this speech signal into frames, and for every frame we have to compute the energy. So, likewise, so we need to split this speech signal into a sequence of overlapped frames, where in that frame the signal to be supposed to be like a stationary. So, that way we split the speech signal into frames, and for every frame we will compute the energy. How do you compute? Suppose the frame contains 100 samples, we will take the square of each sample and sum them, then we will get the energy of the particular frame. So, likewise for every frame we will compute energy, and then we will plot that, and then we will display that. That is nothing but your energy contour, right. So, from this energy contour, where we computed energy contour by taking a frames of a speech signal, then you can clearly notice that the energy contour is varying, and the higher portions or higher amplitudes of energy contour corresponds to the vowel regions or corresponds to the speech is present, and very insignificant amplitudes of energy contour indicates that the speech is not present, or it may be pauses, or it may be very low voiced consonants. So, that way you can able to determine the different regions in a speech and non-speech, right. And then the next plot is showing here is the pitch period contour. It means that here from a speech signal, as we know that as I mentioned that here, if you stretch this speech signal, or if you little bit expand in a horizontal direction, you can able to observe repeated patterns and all, repeated patterns. And here the pitch period is nothing but those repeated patterns for every period. If you compute the time interval for that period, for every period, and if you plot those time intervals, then you can able to observe the plot something like this. You can able to observe the plot like this. So, this is known to be pitch period contour, pitch period contour. See, so from this you can see that the pitch period is not uniform or not constant throughout. The pitch period is varying. That means at the sentence beginning the pitch period is higher, right, and then as you go on, the depending upon the word, the pitch period is slightly lowered, and afterwards for the next word the pitch period is slightly increasing, right, and this word the pitch period also here also increasing, and here you can see within this word there is a lot of variations in the pitch period. At the beginning we have a somewhat lower pitch period, and in the middle we have a higher pitch period, and then afterwards we have slightly lower. So, likewise as you observe here, the pitch period is varying. At a globally you can able to see that the pitch period will be at the beginning we have a lower, then as you move on the pitch period has been increased when you reach the end of the sentence. So, this is a pitch period. What is meant by pitch? Pitch is nothing but reciprocal of a pitch period, because the pitch is nothing but the rate of vocal folds vibration, or you can say the number of times the vocal folds vibration, the vibration of vocal folds in a time, in a unit time. So therefore, here you can see the pitch period is rising for the given sentence. The sentence is माता और पिता का आदर करना चाहिए. This is a declarative sentence. So therefore, we know that in case of a declarative sentence, the pitch period will be the pitch will be right. The pitch will be gradually decreasing from beginning to end. So this you can able to observe here. This is the pitch period we have plotted here. So in case of pitch period, this is pitch period and pitch, they are reciprocal to each other, right. So here in case of pitch period, the pitch period is rising, right, slowly from beginning to end of a sentence, right, from beginning to end of a sentence. So it means that the pitch will be the other way. The pitch will be like from beginning to ending, it will take the trend will be the reverse trend of this one. It means at the beginning the pitch will be higher, and then as you gradually progress towards end of a sentence, the pitch will be lowered. So that's the observation that you can see from the declarative sentence, right. So likewise, the depending upon the sentence, like the syntax or sentence, you can able to see the pitch contour, you can see the shape of a pitch contour or the pattern of a pitch contour varies and all, right. And this is a pitch period, and the pitch contour, the pitch means it's like the reverse of that means reciprocal to this is known to be a pitch contour. So by observing the pitch contour, like one can able to see that this particular sentence is a neutral sentence or a declarative sentence. Or suppose if you see the pitch will be in the other way, like at the beginning we have a higher pitch and at the beginning we have lower pitch, and as you move on the pitch increases, for example, that we can say that it's like, so that way you have, from analyzing the pitch contour at a global level, that means at a sentence level or phrase level, it provides you some information. Even within the words also, the dynamics of a pitch or variations of a pitch will give you some specific information. Suppose a particular word is stressed, for example, then you can able to observe the pitch will be rising, the rising pitch is observed, right. And and again within the word also, we have a word consists of different syllables, right. Each syllable also you can able to observe that there is a variation in the pitch, So that depends upon the context, like the syllable that is preceding to the syllable to be following that, whether the syllable is beginning of a word or end of a word. So all those things have specific patterns of the pitch that can be observed clearly from a pitch contour, right. And there is a plot below this known to be like this is known to be the instance of glottal closure. Here the lines here are here there is a vertical line. So this indicates that this is the instant of glottal closure. It means when you are producing a speech, here the vocal folds vibrate. It means they open, close and all. The moment vocal folds closing happens. So that instant of closing, suppose we can able to mark it, right. So those instants are marked over here. That means by using some signal processing technique, one can able to mark the instance of glottal closure, and those markings were provided here and all, right. And why they are provided here? Because when the vocal folds closes, at the time of closing, you can able to see a sudden rise of impulse in the signal, right. And those narrow pulses, those impulsive pulse, that will be propagated through the oral cavity, and then the resonances offered by oral cavity will be superimposed on that. So that way you can these instants of, and these glottal closure instants are also known to be instants of significant excitation. So it means that when the vocal folds vibrates, you can able to see that at the time of closure, you can see that a sudden rise in the like glottal volume velocity is observed, right. And then afterwards during the closure period, so there won't be any flow of exhalation of air. So therefore the velocity will be 0, and afterwards whenever it starts opening and closing, so during that opening and closing, again you can able to see a narrow pulse, right. And that closing creates the impulsive in the glottal volume velocity, and because of that impulsive strength you can able to see higher amplitude in the corresponding speech signal and all. So, therefore, those instants of glottal closure are very important for analyzing various parameters in a speech signal, and that carries the sound specific information and also the speaker specific and other information is also embedded during that instance of glottal closure. So, that is the reason that here we have just shown that in uttering the speech utterance, wherever the glottal closure instants are taking place, so all those instances are marked over here. And again here you can see the signal is 2500 samples. There are several pitch periods are there. For every pitch period the vocal folds closes, right. So, therefore, for every pitch period we have one mark or at one instant where vocal folds will be closing, right. So, therefore, this particular instance of significant excitation or instance of glottal closure can also be used to calculate the pitch also, because if you take a successive difference between the two instants, that gives you a pitch period, that gives you a pitch period. So, that way you can also compute this pitch contour from this also. Suppose by somehow using a speech signal, if you can able to compute the instance of glottal closure, then if you take a successive difference, then that becomes a pitch period, and if you plot those successive difference in these instants of significant excitation or a glottal closure, you can obtain this pitch contour. You can see here the pitch contour, the pitch period is high, because you can see here the initially the differences are the successive samples or successive glottal closure instants are very far, and afterwards you can see that they are narrower. So, that is the reason that you can see the decrease in the pitch period is observed, right. Here you can see that the almost like pitch period is somewhat uniform. That is the reason that you can see that the pitch period is almost like uniform, right. So, so from these glottal closure instants also you can also obtain the pitch period. And so, then the final one is, this is a spectrogram, and we know that how to derive the spectrogram for a given speech signal, right. So, since it is a non-stationary, so the same thing, the way we computed the energy, the similar to that here also we will handle the speech signal in the form of overlapping frames. For every frame we will compute the spectrum and we will stack those spectral values, so that finally forms the spectrogram. And here you can see that the spectrogram is a wideband spectrogram. See why? Because here you can see that the spectrogram where we observe the vertical striations. So, these vertical striations are difference between these striations or these vertical lines also leads to give you a pitch period, right. So, this is the wideband spectrogram, and from this spectrogram you can able to see that here you can see the spectrogram is plotted from 0 to 4 kilohertz, and you can see that depending upon the various sounds, right, the formats will vary from one sound unit to the other sound unit, right. And here you can see the first pattern or the initial sound corresponds to mata, right. So, therefore, here the initial it is a nasal, right. So, therefore, the low frequency will be dominant, and then it is very like a is there, right, mata a. So, therefore, you can see this there are 3 or 4 formats over here. Likewise, for every sound unit, if you can able to analyze that, here you can see this, the formats are, there is a dynamics in the formats you can able to observe. The second format is lowered, and here the third format will be raised here. So, this is because here there is a place of, there is the occurrence of diphthong is here, mata aur. So, this particular sound unit corresponds to aur. So, that is the reason that here you can see that since au, it is a combination of a and wu. So, that is the reason that here you can see there is a dynamics in the formats, right. Here for a, and then finally it goes to wu. So, therefore, in case of a we have the 4 formats, and coming to u we have the low frequency will be dominant. So, therefore, even the higher formats also moving towards to the lower formants. So similarly, you can also see the dynamics in the formants over here. So here also due to the diphthong, because here the last word is nothing but chahiye, chahiye. It's nothing but e and a, chahiye. There is a diphthong over here, e, right? And similarly, the other places also here also there may be diphthong is there, like mata or pita ka like starts with a and then the other one is back vowel. So there are two vowels like which are very close by. So that is the reason that you can able to see the dynamics in the formats. So that way, by using a spectrogram, by properly analyzing that, we can able to make out different groups of sound units, and sometimes even the